Alrighty, guys, this is my third lesson just to get through section 5.3, and we are not done yet after this one. We're still going to be whittling away. It takes a long time to get through this lesson, or this section. Sorry, not lesson. Anyway, here's my warning. Please read all instructions carefully in this section. The way things are worded will repeat in the next two sections of the book. What I'm trying to get at is this. I'm going to ask you guys to try these problems here. If you did the practice from the previous 2 days, you should have a rhythm for this, for the formula at least. But here is something you're going to see that is a commonly asked thing, where it says, write each expression as a function of theta. And if you don't know what that means, you can't do it. If you do know what it means, it's easy. So let's make sure it's easy. First things first, though. What you're going to notice in this section with all these problems is they are going to give you quadrantal angles. Quadrantal angles. The very last two problems from the previous day's assignment had quadrantals in it. What does that mean? It means a multiple of 90 degrees. So I am going to, come on, there it is. I am going to refer you to this. If I had 0 degrees. Now, they're not doing radians. They're not. They're using degrees. But instead of pi over 2, I could say 90 degrees. Instead of pi, I could say 180 degrees. Instead of 3 pi halves, I could say 270. Instead of 2 pi, I could say 360 degrees. And that is a 1, and that is a negative 1. So if I were to sketch a cosine graph, and the reason why I'm sketching this cosine graph is because they're going to just be focusing on asking me questions about cosine, but let's begin. Example 1. They want me to write this in as a function of theta. So I'm just going to use the cosine, well, in this case, a minus b formula. But instead of a, what do they want me to use? They want me to use theta. And instead of b, what do they want me to use? They want me to use 90. So I'm just substituting. This is a substitution. So I'm using couscous. So I say cosine theta, cosine 90. Instead of a minus, I use a plus. Sine of theta, sine of 90. Now, wait a minute. I didn't draw a sine graph. I didn't. But I'm going to draw one now, so check this out. Wait a minute. Sine graph. We haven't done this in a while. Yeah, I know, but it's doable. Goes as high as 1, goes as low as negative 1. There's 0 degrees. They're not using radians. They're using degrees. That's 90. Oh, my God, that's horrible. I'm going to redo that. It looks so bad. Okay. 0 degrees. That's 90 degrees. Better. That's 180 degrees. There's 270 degrees. There's 360 degrees. What does a sine graph look like? It starts on the line, goes above the line, it goes below the line, etc. All I'm doing is I'm sketching a nice pretty sine graph so I can fill in the blanks here. Cosine of theta. Guess what the cosine of theta is? It's the cosine of theta. But what's the cosine of 90? So let's look up here at my cosine reference graph. This is my cosine reference graph. This is my sine reference graph. The cosine of 90 is 0. The cosine of 90 is 0. So 0 times cosine theta, guess what? Gone. So let's look over here. Sine theta times the sine of 90. What is the sine of 90? Well, it looks like on my graph that if I took the sine of 90, I would get out 1. So what's 1 times sine theta? It's sine theta. So the answer they wanted here is sine theta. That's what they wanted. You are done. That's your answer. That's what it means when they say write as a function of theta. So what they're trying to do, let's do the second example here. What they're trying to do is they're going to give you a sum or a difference formula. So in this case, it's a difference formula. You're going to rewrite it in expanded form using your couscous. So I'm going to say cosine 80 degrees times the cosine of theta plus, because I'm using the difference formula, sine of 180 sine of theta. Now, word on the street is either this side over here is going to cancel out or over here it's going to cancel out. And let's see, we're going to use our reference graph. What is the cosine of 180? Well, if I look at my graph, the cosine of 180 is -1 times the cosine of theta. Plus, now look at our reference graph for sine. The sine of 180, where does it cross the x-axis? Oh, right there at 180. So that's 0 times sine theta. So guess what? These guys, 0 times anything, you're gone. So what's the answer they're looking for this problem? Negative cosine theta. That's the answer they want. If you check the answers in the book, your answers are going to look like this. They're going to look like sine theta, negative sine theta, cosine theta, negative cosine theta. That's your answer. When you write a function, write an expression as a function of theta, that's what it's going to look like. Away we go. I'm scrolling down. Let's knock out a couple more of these. So cosine of 270. You know what? Let's just redraw those graphs so we can use them right here. So here's my reference graph for cosine theta again. I'm going to draw it real quick. I'm going to say at 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. It goes as high as 1, it goes as low as -1. Cosine reference graph starts above the line, then goes on the line, below the line. I'm just sketching a quick cosine graph, and it's a good idea to keep this in your head. Everything we have done up to this point has been done in a certain order for a certain reason so that we're, ready for all this trig that comes our way. There's my cosine graph. Here we go. Here is my sine reference graph. My sine reference graph at 0 degrees, at 90 degrees, at 180 degrees, 270. Remember, quadrantal. All these questions contain quadrantal angles. High as 1, low as -1. I'm going to start on the line because I'm sine. Above the line, below, back on the line, below the line. And that is one period of this function. That's all I need for reference. And let's go get this. I'm going to do the cosine of 270 degrees times the cosine of theta. It's a difference, so I'm going to put a plus. Sine of 270 sine theta. Let's go get this. What is the cosine of 270? Look at your graph, and guess what? That thing is 0. So 0 times the cosine of theta. This side's going to cancel out. What is the sine of 270? Look at your graph. Sine of 270 is -1 times what's left over here, sine of theta. So what is the actual answer they want for example 3? Negative sine theta. Boom. That's what's called writing an expression as a function of theta. Now, nobody has asked me this question yet, but that's because you can't. Get it? But you might be thinking, well, why don't I just punch in on a calculator the sine of 270 or the cosine of 270? You could, but I know for a fact when they say exact values, you will have to take tests in AP Calc without a calculator. There are some tests where you should know the answer. And that's why I also say, you know what, it doesn't hurt to remember what the basic graph, the parent function, looks like. We spent so much time on this parent function concept all school year because it never goes away. It helps you visualize what's going on. So yes, could you use a calculator to find the cosine of 270 is 0? Sure, if you're in degree mode and you remember you're set that way. In fact, down below here, my last example, cosine of theta plus 180 would be cosine theta cosine 180. Minus, because it's a sum formula, minus the sine of theta, oh my gosh, let me start that over. Woo! Sine of 180. That was really bad. But you know what? I've already done this in my head. I know this part's gone because the sine of 180 is 0. It's done because I have the graph in my mind. And this guy's negative 1. This guy is cosine theta, so my answer is negative cosine theta. That's what it is. That's what it is. All right, scrolling all the way to the top. Page 213, 43 to 50. You should be able to do those problems.